really great to see all this turnout, so many people, sorry, eager to learn new stuff and to learn, to broaden their view. Any minute now? Yeah. So now, sorry for that. Okay, so it's great to see so many of you here wanting to learn new things and to expand your way of programming. And I think that's one of the great things about the JavaScript community. So, for example, who here would consider themselves a functional programming enthusiast? See, right, quite some hands. That's fantastic. I think even though JavaScript, it's not Haskell and it won't be, but you can clearly see that functional programming has very much influenced the way we program in JavaScript. And I think that functional reactive programming, which I will be telling you about in a minute, is pretty much the same way. So this FRP hasn't made its way to my boring stack yet, but it has definitely influenced the way I program and the way I think about my programs. And this is a pretty great thing. And you can see this in the greater JavaScript ecosystem as well. I think FRP is really starting to influence the greater community. So you can see this, for example, in Angular, which has been shipping the most popular FRP library in JavaScript, RxJS, for quite a while now. And you can see this in, like, if you squint a bit, the way we program our React applications can be modeled as a reactive system. And actually, the observable, which is the primary building block of FRP, is actually on its way to be standardized in JavaScript, although it's still early days. So it's really it's really starting to influence the JavaScript community. And so that will be my main goal tonight, to, well, first of all, to get you excited about FRP and to hopefully help you appreciate it, but also to, even if you do not go all in, that you will still apply this to the rest of your programming. And I hope to achieve this by showing what it's like when you do go all in. But to get there, I will have to take a short detour, so bear with me before I actually get to FRP. So how will I get there? Well, I'll first start by discussing how we introduce bugs to our code, how they exist, or how they occur. And then, and only then will I introduce FRP, because I think it provides a very nice way of dealing with these bugs. And then after that, I will do a short demo of what it looks like to really program write a program using FRP. And then if there's some time left, I'll try to introduce a short way of really going all in, but I think you can probably think of that by yourself as well, so it's not that bad if I miss that. And then at the end, I will draw some conclusions, of course. Is there anyone who can tell me who the most famous Dutch computer scientist is? Edgar Dijkstra, exactly. So I thought it would be fun to start with a quote by Dijkstra. It's mostly just funny, but what he said is, if debugging is the process of removing bugs, then programming must be the process of putting them in. Well, I hope that it's that we program more than bugs, but there's actually a lesson in here, I think, and that is, like, debugging is good, and it's great that we're removing bugs from our software, but it would, of course, be better if we would just not introduce these bugs in the first place. So how can we do this? Well, let's first consider what a bug actually is. And basically, a bug is software behaving in a way other than what we expected it to do or what we intended it to do. So it's when we have difficulty following our own code. So how does that happen? Well, consider this piece of code. So this is actually pretty simple, right? So we have a counter, and by calling the increment function or the decrement function, you can actually alter the value of that counter. And we can also, this is relatively easy to follow, but I would argue that actually this code has the seed of becoming difficult to maintain later on. So imagine that our increment function and our decrement function, they start to increase in size. We're adding more lines. At a certain point, we're refactoring stuff, and these functions end up in their own files. And then at a certain point, if you want to modify the increment function, then it's all of a sudden it's referring to this counter variable, which is not even located in the same file. And you have to be aware of the rest of your code base before modifying this function, because that could influence the behavior of your function. So we need to find a way around this. So how can we do that? Well, basically it's by writing our functions in another way, namely by avoiding modifying stuff outside of the scope of the function and making it what's called a pure function, which probably many of you already are familiar with. But it means that you pass everything, or with some hand waving, it means that you pass it everything that it needs and it doesn't modify anything outside it. So what would that look like? Well, it would look somewhat like this. So, apologies for this, I use TypeScript, but so you pass it a value, namely the current value of the counter, and it returns, instead of modifying that value, it returns a new value. So for example, for the increment function over here, you pass it the current value of the counter, and it returns that, it returns a new number that is one higher than the value it received, and the same for the decrement function. So at this point, if you're modifying this function, you don't need to worry about whatever is happening outside of this code. As long as you're getting past a certain value, you will return the correct new value. So this is nice and all, but of course this is not how you would, or we still need to keep track of the state of our counter somewhere. So if we were to actually use it, we'd probably we'd have to do something like this. So we pass it the current value of the counter, and then the return value, we assign that back to the counter variable. But of course, when you start to actually do this, usually you don't just want to increment the counter. You want to do this, for example, in response to user input. So we write an on-click handler, and then which is called when the user clicks a button. And then the increment function is called again, and it modifies its value. But the observant ones among you will have noticed that this function again has side effects. It's modifying this counter variable, which is located outside of the scope of this on-click handler. So this is a bit where we get stuck. We want to program as much as possible with pure functions, but we're somewhat forced to deal with side effects, with modifying things outside of the scope. So keep that in mind for a bit, and I will quickly introduce FRP. So yeah, I got this really nice slide, which came with the template. So the primary building block of reactive programming is the observable, which I will introduce in a bit. And it turns into functional reactive programming when we apply functional concepts to this observable data structure. So what is an observable? Well, basically it's this, or actually it's just this. So by convention, we append a $sign to the name of an observable to indicate that it is an observable. And basically it's an object that represents values that are produced over time. So they have a subscribe method, which you pass a callback, and that callback gets called every time a new value is produced. So for the more visually oriented people, it's somewhat like this. So this is an observable that first produces the value 1, then it produces the value 2, and sometime later it produces the value 3. So in this case, it would call the do something function first with the value 1, then with the value 2, and then it would call it with value 3. So it's actually a rather simple concept, right? And as I said, you can apply some functional operators on this, and these are usually provided by an FRP library like RxJS or Bacon or Kefir or whatever, but they mostly agree on the initial set of operators, even though they might be named different. But the first one might look familiar, the first one that I'm going to introduce. So this is the map function, which is pretty much like the map function on an array. So you pass it a transformation function, and then the map function will produce a new array that contains the values of the initial array, but then passed through that function. So in this case, I gave it a function that multiplies a value by 10. So if we had initial array of 1, 2, 3, then it will produce a new array that had the values 10, 20, 30. So in the case of this observable, we have an initial observable that at some point in time will produce the values 1, then 2, then 3. But we receive a new observable that will actually produce the values 10, 20, 30 when the initial observable produces values. The second operator might seem familiar as well, because for arrays, this would actually be called reduce. And basically what it does is you pass it a function that receives an accumulator and a new value, and then it will combine those two. So in this case, I'll add them together. So we get a 1, then we get a 2, which is added to the 1 to produce 3. We get another 3, which produces a 6 in the output observable. Get another 4, makes 10, and 5 makes 15. You get the point. So, and actually, these operators are not even limited to a single observable. So, as an example, a really simple one is the merge operator, which simply produces a new observable based on 2 initial observables that produces new values whenever either of the input observables produce a value. And these operators, they might all seem rather simple, but once you start to combine them, they grow really powerful. And what you should note is that these functions that we pass to these operators, these are all pure functions. They do not modify anything outside of this function itself. They receive input, they produce some output. So this allows us to write our applications with as much pure functions as possible. So I'm going to show a demo of that. So what we're going to do is we're going to push side effects to the edge of our application. So we're going to need to do some side effects to receive input from the user, and we're going to need some side effects to produce some output to the user. But as much as possible between that, we want to be pure functions. So what would that look like? Well, I'm going to, let me see, yeah. So we're going to produce this application. Oh, that's my full screen. So as you might imagine, we have a simple counter, and we can press +1 or -1 to modify this value. So what does this look like? Cheers. So we have a markup like this. So 2 buttons, one with the ID increment button, one with the ID decrement button for the +1, -1. And this element with the ID of counter to show the actual counter value. And we want to actually make that counter work. So what would that look like, or what could that look like using observables? Well, basically we start by getting the element, the input, the increment button element, and we create an observable that will produce values whenever the click event is fired on that button. So that works like this. So we say observable.fromEvent, pass it the element, and then say, okay, for click events, I want to receive values. And we do the same for the decrement button, of course. So we have this element with the ID decrement button, and we capture click events inside an observable. And we can save these two to an increment click observable and a decrement click observable. So these are our input observables. And this is the part where we went from the input side effects into the nice and clean observable land immediately. And at the end, we're going to assume we have a nice observable producing new counter values. So whenever the counter changes, it produces a value, and we want to display that to the screen. So we would do that like this. So we assume for now this counter observable, we subscribe to it, and whenever we receive a new value, we look up the counter element, and we set its content to be the counter value. So then, how do we get from the input observables to the output observable? Well, we start by taking the observable producing new events whenever, or producing new click events whenever you click it, and we map that to the value 1 because we want to increment our counter by 1. The same for the decrements, but then we map them to -1. We can merge these together, so now we have a single observable that produces 1 whenever you click the increment button and -1 when you click the decrement button. And of course, when the user hasn't clicked anything yet, we want it to produce a value 0 for initially. We can then use the scan method that I introduced earlier to actually combine these values. So we start with a 0, and then whenever you receive a 1 or a -1, you add that to the previous value. And basically that's it. So now we have this count observable, and we've already seen how we use that to display values to the user. So let's say we want to modify this code right now. So I'm not sure if it's an urban legend or not, but people say that there are skyscrapers where for superstitious people they've skipped the 13th floor. Has anybody ever seen such a? Do they actually exist? Yeah. Okay. Cool. So let's say we have to make a counter for the elevators there. So we want to modify this code to skip the 13th floor and to actually move on to the 14th or the 12th whenever we get there. So let's take this code we had up there. So this is the code we just saw in the slides. Is it visible enough? Oh, I can zoom in a bit. This is clear enough, right? Yeah. Okay. And one thing that I did not mention yet is another really nice advantage, in my opinion, of pure functions is that they're really easy to test. So we'll see that as well. So let's start with, so basically this is the meat of our application, right? This is the thing that updates our counter value. So let's extract this into its own function because that's nice. Update counter, oh, I should really, oh, I got this. So I've already, what was the shortcut? This. So I've already extracted this function before, but this is the same function, right? We receive the accumulator and the new value, and we return both added together. So now to modify this, as I said, it's really easy to test pure functions. So I've already written some tests for this earlier. So these tests test our increment and decrement. But now let's write a test for skipping the 13th floor. So it should skip the number 13 when incrementing. I usually type more accurately. So when we come from 12, we add 1. We actually want it to end up at 14 rather than 13. So now increment. So we want to do the same for decrementing, but then when we come from 14 and we subtract 1, we actually want, we actually want to end up at 12 instead of 13. So let's run these tests. Oh, I have to zoom this in as well. So let's run our tests. Hopefully 2 will fail, right? So we see 2 passing tests, which are the ones I wrote initially, and 2 failing tests. And as you can see here, we expected 14, but we got 13 right now. So let's implement this. So basically, what we need to do is, well, if the value that we're calculating right now, if that will end up at 13, all we have to do is multiply the new value we get by 2. So then we will end up at 1 higher or lower than where we were. So now let's rerun our tests. Hopefully all are, yes, so all are succeeding. Oh, this is not actually that interesting. I'm restarting the app. So here we are now. Let's see whether it actually works, but we have the test running already, so having some faith, but then again, it's a demo, so you never know. So I go to 12, now let's pray for me. Yes, so we actually skipped the number 14, and then that's basically number 13. And that's basically all there is to modifying this application. You should note that I didn't have to think about anything other than this function. Nothing else was relevant. And for testing, I could just input some value and check the output value. So this is rather, I mean, the concept of FRP is maybe difficult to grasp initially, but once you can read that, then it's rather easy actually to modify your code. So yeah, how am I for time? 7 minutes. Okay, that's good enough. So so basically that's FRP, and so what observables are really nice for are for asynchronous data. So and what I've hopefully shown is that it's that occurs more often than you might think. So user input is asynchronous. Displaying things to the user can be asynchronous, but it could also be, for example, if you have a backend that you're merging several microservices responses together, which is also asynchronous. So these are all cases where observables might come in handy. So now I'm going to actually recommend, I'm going to name yet another JavaScript framework, but bear with me, because I think, so let's just cut to the chase. It's CycleJS, which is a really nice framework, which I actually wouldn't recommend you to start jumping in and use it in production right now, because it's rather small in terms of community. So although not, it's no React or Angular, for example. But I would very much encourage you to try to write an application using this, because it really helps you to think reactively. And basically, the way creating applications in CycleJS works, it's pretty much like I just showed you, except you don't have to deal with the side effects on the that I had to do initially. So you don't have to convert the input events to observables, and you don't have to convert the output to, or take the output observable and then modify the DOM manually. CycleJS takes care of this for you. So how does this work? Well, let's say this is your app, your CycleJS app. And if you want to update the DOM, CycleJS provides a driver for you. That's what it's called. So in this case, a DOM driver. So what you do if you want to update the DOM in CycleJS, you don't have to do that manually. You simply pass a description of what you want the DOM to look like, much like virtual DOM in React, and you push that onto an observable that the DOM driver listens to. And likewise, if you want to respond to user events, you don't have to manually listen to events or whatever. The DOM driver can also provide you with an input observable that produces new descriptions of whatever event just occurred. And that means that your app simply consists of transformations of input observables to output observables, and your entire app can remain pure. And this is just, and this holds for all side effects. So not just the DOM driver for interacting with the DOM, but also, for example, if you want to perform an HTTP request, there's an HTTP driver, and so you push a description of the request you want to perform onto the output observable, and then the HTTP driver also provides you with an observable that provides HTTP responses. And there's drivers for pretty much every side effect you can think of. So if you want to make WebSocket requests, if you want to interact with the browser history, you name it, there's probably a side effect or a driver for that. And of course, you can write your own, but then you still have to deal with side effects yourself. So yeah, I think that basically was it. So to recap a bit, I started with bugs occur when we can't follow our own code and when it does things we don't want it to do. This often happens when we're dealing with side effects in a function, because then we have to take the entire code base into account, which can especially become difficult when, for example, a new colleague jumps in or something. So to avoid side effects, we use pure functions, and programming with pure functions can be practical when you do FRP. So if you're interested in this, I I sometimes write about things like this on my website, vincenttunru.com. There's also a summary of this talk over there. I will link it on the meetup page as well, so you can read it back in your own pace if you're interested. So, yeah, I think that was it. So thank you for listening.
We have around 3 minutes for a few questions before we switch the speakers. So if somebody wants to ask a question, raise your hand. I'll pass the mic.
Any questions? Yeah.
Hi. Thank you. That's interesting. One question, just out of curiosity, because I'm imagining the code that would do the same thing in like old-fashioned and not so cool style, like with side effects and everything, and I think it would be much like shorter. Let's say.
Like without the...
yeah, without observables, well, the way you showed in the beginning. So what I'm thinking now is that I'm just curious, how do you actually start writing the code in this way from the very beginning, or you're like, there is some kind of a moment that you know, okay, this is the time when I need to convert my code into something more like reliable, I don't know, testable, whatever.
Like I start from observables and move
the
other way around?
Do you start with using observables in this kind of code, or you start with like old-fashioned style and then at some point convert it to FRP style?
Yeah. So basically, what I mentioned in the beginning is it's not part of my boring stack. So I don't usually start writing my code in this unless I want to toy with FRP. So using observables is mostly in my I don't usually go from one to the other because I know so there are some downsides of FRP. I think the biggest one is people don't really know it. So if you work with multiple people, you don't use it. But if I for my own project or something, when I do it in this style, I don't really switch. But I haven't done really large projects yet, so who knows?
All right, a few more questions. One in the back.
Excuse me, sorry. Are the observables part of the ES17 spec?
No. 17 is, I think it's already finalized.
Oh, so it's...
Or almost. No, not yet. But no, they're not. So I think it's at stage probably 0, maybe 1. So and there's still a lot of discussion about it. So it was also influenced by the... so there was also a proposed extension to the promise specification where there were ways to cancel it, and that influenced the observables spec, and then that proposal for promises was thrown away, so now the observable spec has to be redone again. But there's definitely momentum behind it, but it will take probably a few years before it's actually in the spec.
Okay, and one other question is, what is the underlying driver of observables in C? Is it sockets or intervals? Or
no, it's just behind the scenes it's all callbacks, so it's just a single-threaded JavaScript.
Okay, thanks.
Let's do a few more questions until the second speaker is ready. So just raise your hand, I will come with the mic.
So I think it's very difficult to make it fully functional because you always have the input-output from the browser, right? If you manipulate the DOM, there might always be another event listener that does something or modifies some other state outside of your knowing. So how would you prevent that?
Yeah, so in the style programming I demoed, so what you try to do is, or you accept that you have to do some side effects, but you want to minimize it as much and really limit that to input and output, and then move it into observables as soon as possible. So at least the large chunk of your application is written in observables. But if you use CycleJS, for example, then yes, there are side effects, but you don't have to deal with them in your own code. It's CycleJS drivers that do that. So in that case, you actually can be fully functional, and the function that produces, you don't manually manipulate the DOM, but you just produce an output. So that's still a pure function. from a certain state to a description of what the output should look like given that state.
Right, but if I would like to start tomorrow with, converting my legacy project to reactive functional, then how is that possible, or
I mean,
would I need to
well,
start from scratch?
I haven't done that, so it's purely my imagination at this point. Fully reactive then is basically a full rewrite if you want to do that, and you have to consider whether it's actually worth it. Like if your application is running fine, then why change it? But I think you could, for example, in Angular, it's rather limited the way, or you can go all in or very far with observables. But basically, you can use it over there by just transforming incoming HTTP responses into some form values or something, and then you can just do small parts. But then you have to consider whether it's worth it because it's something new to learn again. So yeah, converting your application fully, I would think twice about that. But writing more pure functions is definitely always possible.